Oh, listen to this, baby. We may be visiting aliens sooner than you can imagine. Stephen Hawking, Mark Zuckerberg, and a Russian entrepreneur named Yuri Milner are teaming up on a program called Starshot, which will send a swarm of iPhone-sized probes, teeny tiny ships, to Alpha Centauri, that is our nearest solar neighbor outside, or our nearest star neighbor outside of our solar system, in search for intelligent life. And here to explain it all, it's Dr. Michio Kaku, theoretical physicist and professor at the City College of New York. Welcome back.
Glad to be on the show.
So I can't think of a person, you don't have to be an astrophysicist or an astronomer to look up in the night sky and think, how do we get there? And we've all conceived of these giant spaceships piling at us millions and billions of miles away. But what's happening with this project?
Well, Captain Kirk, watch out, because we're going to send starships throughout the universe the size of a postage stamp.
Even smaller than an iPhone.
That's right. Now, why does the Enterprise have to be so big? Why do rockets have to be so big? Because they have to carry their own fuel. So why not put the fuel on the ground and with lasers shoot this fuel into outer space to propel postage stamps, nanobots with artificial intelligence to the nearby stars. This is with off-the-shelf technology.
Yeah.
That's what's so novel. We don't have to wait for warp factor 5, warp engines. We don't have to wait for black holes. No, off-the-shelf technology.
And they're going to go 100 million miles per hour, is that true?
They're going to go up to 20% the speed of light.
Okay.
So to the nearest star in just 20 years. This is amazing that within perhaps our lifetime, perhaps our children's lifetime, we may get first images of a planet going around another star system.
So once those packets get there in 20 years, how long will it take for them to beam some of the images and information back to Earth?
Well, each postage stamp has sensors, TV cameras, and all sorts of devices so that when they reach Alpha Centauri, they can radio the message back to Earth, and then it would take about 4 years.
Okay.
So once they reach the nearest star, it would take then 4 years to then radio back the information.
Now, this team, including a former head of NASA's Ames Research Center, has said it's going to take 20 years from now until they actually launch, and then another 20 years. So
what's the bottleneck?
Yeah.
We have off-the-shelf technology today. The problem is the energy of the laser beam. You need 100 gigawatts, which is about 100 nuclear power plants.
Wow.
Generating power of a battery of laser beams shooting into outer space and then hitting a sail, and then hitting the sail, which then pushes the sail to 20% the speed of light. That's the problem. The problem is we have to have huge lasers on the planet Earth.
Yeah.
Eventually, maybe
And
on
we
the
don't
moon.
have anything like that right now, do we? What's the closest thing we have to something with that much power, aside from a nuclear power plant?
Well, in California, Livermore National Laboratories, we have a laser fusion machine, a gigantic machine which uses laser beams to create a mini hydrogen bomb right there, okay? However, that only works for a fraction of a second. We have to have 100 nuclear power plants of energy for 2 minutes. 2 minutes to then shoot this thing up to 20% the speed of light.
Yeah, but people still are really kind of sketched out by nuclear power. You know, especially after Fukushima, people are worried about what can happen, the what-ifs, if there are accidents and meltdowns and natural disasters.
Right. Now, it doesn't have to be a nuclear power plant. It could be a coal plant. It could be an oil-fired plant.
Yeah.
Whatever. We need 100 gigawatts of power to energize the laser beam.
Yeah.
And then you have to aim it just right. Because if you aim it wrong, it'll miss Alpha Centauri by several.
And then it's going to start blowing stuff up. Now, in Alpha Centauri, do scientists believe that there is something like Earth, that there is a habitable planet there, possibly with people just like you and I having the same kind of conversation?
Well, Alpha Centauri is a strange system. First of all, it's a triple star system, just like in Star Wars.
Yeah.
Not one, not two, but 3 stars going around each other. And we think
including Beta
planet.
Centauri.
Well, we think there is a planet there, but it's not confirmed yet. But we think there could be a planet going around.
How big?
Perhaps Earth-size. But again, we get contradictory information. It's not been verified yet. But one study shows that there could be a planet going around a triple star system.
And what would we need to verify?
Well, we have to verify its size, whether or not it has like oxygen capable of carrying life, whether it's what is called the Goldilocks zone. Not too close, not too far from the mother sun, but just right to have liquid water, which is the universal solvent.
But it's got 3 mother suns. It's so modern. What a wonderful family.
Right. Remember in Star Wars, you look up and you see 2 stars in the sky? Yeah. There you would see 3 stars in the sky.
Hot, but it'd never be black. You'd never get any sleep because there'd always be a sunrise going. All right, Dr. Kaku, thank you very much for coming by. Dare to dream.
Yeah, right.
And
boldly go.
That's right.
We're talking starships now.
Well, maybe the aliens are already here and they can look over the plans and be like, nope, nope, yeah, that's it. Hopefully. All right, thanks again. Come back soon.